Thank you very much. Antti and I were just talking a little bit before we came in. You know, a lot of these conferences kind of work like, like a rock concert. All the opening acts are the first 2 days, and so this has really been no exception. The big show is happening right now. And for those of you who are confused, Jeremiah Grossman's in another conference room. Okay. Anyways, so today we're going to be talking about database trust. Essentially, trust in the real world is something that's built on experience. It's built on reciprocation. More importantly, it takes time to build. But I think if you're in this room, you guys probably already know, in IT, trust is a completely different thing. It's a completely different animal. And once you assign any type of privilege to an account or a system, the privileges are instantaneous. And they can permeate through all kinds of levels that administrators don't always understand. And so today, we'll be talking about some of the issues surrounding those trust relationships and how penetration testers like myself and Antti, along with real-world attackers, are leveraging these issues to gain access to your systems, your applications, and your sensitive info. So I think I lost my clicker. Oh, there we go. There we go, okay. I'm Scott Sutherland. I work for a company called NetSPI out of Minneapolis. I'm a senior security consultant. I've been in IT for about 10 years, but for the last 6 years I've been focused in security specifically. So heavy focus in penetration testing, web application penetration testing. And that's actually, led me here today with some of the research that we've been doing over the last 6 months or so. With that said, I'll maybe let Antti introduce himself.
Hey all, I'm Antti Rantasaari. I'm Scott's co-worker at NetSPI. I also work on web application security, penetration testing. Grew up, got educated, got my IT background in Finland, so that explains my funny accent.
Thank you, Antti. All right, so what we're going to be talking about today, first, we're going to talk about some of the core issues that we believe are really contributing to these trust problems. We're going to be talking about 3 of the common attack scenarios that we see when we're doing penetration tests and that we've heard about from our clients as well. Most of these attacks are not going to be brand new, bleeding edge type of attacks. They're relatively well-known attacks that we've just kind of combined to kind of help inform you guys that these are still real problems. Last but not least, we're going to give you 5 fixes to help stop the bleeding. We're not going to give you a comprehensive list of fixes. We are going to give you some potential solutions that are relatively low cost that you can use to help improve the security of your application implementations. And then I have QA on here, but if we have enough time at the end, we actually have a short demo too to actually show you how some of these work in a VMware environment. And if we can do that, we'll get to that and answer any questions you have at that time. All right, so what's the first issue? First issue we have is budgetary constraints. I think this is probably not a big surprise to most of us. There's not I don't know of a single company that we work with who has an unlimited security budget. So what does this really mean? I mean, I think we have a limited application security budget that we're going to have to spend money on. Very specific things, we're going to have to prioritize it. And I think we all went to school learning about security, reading the books, taking the certifications, and thinking we want to do best practice across the board for every application in our environment. But as a lot of the people have talked about so far, that's just impossible. There's hundreds of applications, if not thousands of applications in enterprise environments that are homegrown or third party. So what ends up happening? We spend that money on high value applications. And what high value applications typically means in most enterprises are applications that handle sensitive data like payment card industry information, healthcare data like HIPAA, social security numbers, HR data, all kinds of things. Also applications that support critical business functionality. And very often these applications are internet facing. Surprise, surprise, we're kind of a web-based world. So we end up spending all our money here, and what that really means is we're doing secure design, we're doing threat modeling, we're doing static and dynamic code review, we're doing penetration testing on kind of the end of that. And that's all good. I'm not saying that's wrong. You have to spend your money wisely. But the problem is why all these applications are getting hype, getting all this attention, the low-value applications are getting the shaft. So they're being rolled out into the same environment as these high-value apps. They're sharing all these trust relationships on the front end, on the back end, and they have way more security bugs that are what attackers are going to leverage. I mean, it's basically a path of least resistance, right? We're not going to bang on the high-value app when we know we can get in through the front door using this low-value app and then eventually get to the data we're trying to hit. So what are the issues? First, we have the second issue here, we have lack of ownership in gray areas And when I say gray areas, I'm really talking about team responsibility. I think anybody who's a developer here, server administrator, it doesn't really matter what role in IT, you're exposed to this. When we implement an application, we have the server team, the development team, the database team, the network architecture team. Everyone's involved in making this happen. And the problems occur when people don't really know what their role is. And more specifically, I'm talking about how we're assigning privileges to different types of accounts. So for the first example, we have database accounts. Very often I'm talking with different groups of people, and database administrators very often feel that the privilege should really be defined and set by the application owners. Unfortunately, the application owners don't always know what the exact amount of privileges their application database accounts needs. So what ends up happening is it falls through the cracks, and application database accounts actually end up with what equates to database administrative access in on-production systems, which is really scary. That means when you break through your low-value application, you're getting full reign over the back-end database. We'll see how that works in a little bit. The other scenario here that we have has to do with service accounts. This kind of has to deal with the server team and the database team. Once again, we kind of have an overlap where the database team feels, hey guys, the service account that's running my SQL server is an operating system account. You own it. You configure it, and the server guys are saying, we don't know, what privileges your SQL server really needs, so it should be your call. And so ultimately, they end up giving it way more access than is required. All in all, the end result here is that we're getting unauthorized access to database information and server functionality. Another thing I'd like to note just briefly here is that very often I find these type of issues on unmanaged systems or legacy systems. They've been in the environment for the last 10 years. They've gone through owner after owner, and finally people have just washed their hands of it, and they're just kind of sitting on the network and no one wants to touch them. So they have these kind of stagnant configurations that never get touched, but they are leveraged by attackers very, very regularly. Also, vendor systems. I'm sorry if there's any vendors in the audience who I'm offending. It's not my intent. But very often vendors promise these application and network devices that you can drop in. They're point and click. They're one-button solutions. And they promise that they're secure. Well, the reality is very often they're not. I mean, I think probably 30% of the systems that I use to get into initially during some of the penetration tests are actual vendor boxes that are configured with domain admin, have default credentials, have default interfaces, all that type of thing. All right, so last but not least here, we have lack of education. This is another kind of no-brainer for most people, I think. A lot of the coders are not receiving the training that they really should be, and I think a lot of people think it has to be an expensive thing. It doesn't. I don't know if you guys are aware, there is an organization, kind of unknown, OWASP, you guys heard of it? They actually supply all kinds of training material. They have development guides, all kinds of resources that you can send your developers out to online that they can use, in-house for a very low cost. Additionally, you can send them to get certified and get certifications, go to SANS training. Those are a little more pricey, but I definitely recommend doing some kind of training, because your best defense is really going to be having developers that are aware of the best practices. Another group that needs education are the database and server teams. Very often, they kind of understand themselves in a silo, but they don't understand the effect that they have on other people and other groups, and how their inherited permissions can affect other people. And we'll actually see how this works out in the upcoming scenario. So the result, we have input validations that are on these low-value apps that are being leveraged by attackers, and of course, all the other stuff that comes in the OWASP top 10, all the business logic issues. Use of shared accounts, and excessive privileges on database links, and pretty much every other type of account in the environment. So next, let's talk about the attack scenarios we're going to be hitting. First of all, we're going to be talking about excessive database and service account privileges. This is the simplest attack that we'll talk about. They'll get progressively more complex, or actually, let me rephrase that. They're all pretty simple. We're just going to start layering attack on attack, and you'll kind of see how that works out. The next one will have to do with shared service accounts and leveraging them. And last but certainly not least, database links. Another thing I want to note here is these pen test techniques that we're talking about leverage all native technology. This is important for a couple of reasons. A, you don't have to download a toolkit that might set off AV. You don't have to download a toolkit that might scare the heck out of your client. And also, it reduces the risk of doing the assessment. Because you're using native technology in these attacks, you have a lower likelihood of actually causing any type of service disruption on any of these layers that we'll be talking about. All right, so batter up. Attacking MS SQL server accounts with excessive privileges. So service account, just to give you guys a background really quick, are used to run applications. They typically run in the background, so they're not the type of account that you're going to use to log in interactively like your normal user account in the morning. They are used to run all kinds of applications, antivirus, web servers, and of course MS SQL. Also, one thing that's really important to note is that the service accounts, the applications are going to inherit whatever privileges you assign to that service account. And I think there's kind of a myth surrounding this, because we talk to a lot of developers, a lot of server admins, a lot of database admins, and they seem to have this understanding or lack of understanding that they think the service accounts are untouchable by a normal user, that they're not accessible. Once we configure them, they run in the background. You can't touch them. It doesn't matter if I assign them all the privileges in the world, because no one can use it. That is completely false. There are many, many, many ways to do this. The two big ones are XP command shell, extended stored procedure within MS SQL. This is, once again, it's been around forever, basically since its inception. Database administrators can use it to run commands as a service. Server administrators very often inherit their permissions, so they also have what equates to database administrative access. They can run local commands as a service. And then, any developer that's pushing code against the database, and let's just broaden it to maybe the entire internet. If you have anyone who is savvy and can identify the SQL injection, now they can run code as that's in that service context. So the big problem here is that very often these accounts are configured with excessive privileges on the local perspective and also from the domain perspective. So very often if you have a database server that only needs to operate locally, you're not going to give it a domain account. That's good, but unfortunately people give it administrative rights. The same applies to database servers that do need to communicate with the network. People give them actual domain privileges, and I know a lot of you think, well, that's maybe a rare case, but the reality is we see it quite a bit out there in the real world when we're doing these types of tests. So quite obviously, probably the best practice here is to use local and domain accounts with least privilege when configuring these service accounts. So next up, we're going to go through all these scenarios. There's 3 scenarios. They're all going to be using this network model. It's pretty straightforward. We kind of have up here our internet layer where pure evil lives. We have all our presenters from earlier today sitting out here attacking your network. Also, we have our DMZ with our application servers, both our low value and our high value app servers. And then behind that, we have our internal network where we have kind of our database servers and everything else, like our Active Directory and workstations, et cetera. So what typically happens here is Attacker Joe or Captain Evil comes through the cloud of pure evil or death or whatever, is able to inject over here on your low value application, which hasn't gone through, proper security review. And because of the kind of inherent relationships between these firewalls, we're going to be able to forward the request here to access the website. We're actually going to force an arbitrary SQL query, which is going to come back here to this database. And now we want to find out what privileges we have on the database. So we're going to try and run, just quite simply, that command shell extended stored procedure that we talked about before. And this is another myth I kind of want to touch on. I think a lot of, even security professionals who've been around the business for a long time feel that this is the biggest problem in web security or database security right now. Because they feel that if it needs to be removed, it's on the server, that's the problem. The finding is that it's on the server. But the reality is, even if you uninstall it, there are stored procedures that allow you to reinstall it from the DLL, re-enable it, and then use it for your attacks. So simply uninstalling it isn't the solution. And I just want to make that clear for people who are unaware of that. The real problem here is that that you're assigning way too many privileges to this application's database account. So we find out, we run some commands locally, we find out we're a domain admin. We're very, very happy right now. As a pen tester, we also want accountability, so we're going to add ourselves as, basically we want to create either a domain administrator or we want to find a way to get access to HVA. And so initially, we give a try. We try to connect to it directly, but it says we don't have privileges because the smart database administrators over here have removed all unnecessary groups from their sysadmin role, which is good. Unfortunately, the reality is when I'm a domain admin, I can simply go to the Active Directory, add myself to the database groups, and now I have the rights to the high-value application database. That includes the data, that includes the server, that includes all your client-facing content where I can inject all my kind of lovely client-facing attacks and now spread this to all the clients. Reputation damage will ensue. So that's the gist of it. Let's kind of break it down quickly. First thing we did here was SQL injection. I think you all kind of know how to fix it. You're kind of an educated group, so I'm going to move on. Basically, it's input validation, store procedures, parameterized queries. Number 2, we've kind of beat with stick for a while. You have excessive privileges on the database account. And number 3, we're running as a service account that has way too many privileges. In this case, domain administrator, which allows us to basically do anything that we want. So let's look at a real world example. This is pretty much the most basic SQL injection example you're going to see today.